26 years has gone, but time keeps flying, especially when you're busy. And it looks like 2026 is shaping up to be an epic year for agentics. If I'm any indication of the opportunity itself, I see tons and tons of things coming and opportunities. So I feel like we're on the cusp of something big. We've been talking about this for a while. Happy New Year, everyone. It's really good to see you. I see Ocean and Rob. Welcome back. It's been a few weeks. I noticed the last time we did this was I think the 12th of December. So it's been 3 weeks.
Yeah, that's right. Happy New Year. Happy New Year. It was a great set of holidays, and it was nice to step back a little bit. I had a little analog time, and then get incredibly excited about everything that's taking place. It feels like we're now at the point where the entire world has come to terms with the fact that this is a serious retooling that is taking place, and remarkable to see how the year culminated in 2025. And it's going to be really exciting. Yeah.
Well, I will say the double usage for Claude over the holiday break was very nice. Now, it wasn't necessarily nice to our spouses and significant others who are forced to say, "Why does he keep disappearing to his office every 5 minutes?" But yeah, I don't know if they doubled it or quadrupled it, but I never made it above 11% usage of my quota over the last 2 weeks, and I had this thing cranking. So it's good that I noticed that everybody was I've been getting tons of messages and sort of showing me of all the things people are creating right now, and there's some epic development happening, and I'm excited to sort of see what everyone else has been building over the last few weeks. Oh, I see the whole cast of characters has joined us today. Hey, Brad, how's it going?
Great,
Good,
great to see
it's
you. Merry Christmas, Happy New Year. Dog's barking, so I'll come back later.
perfect timing. So this week we don't have like a particular structure. I think we've got Ben said coming on
And has got some stuff. Yep.
yeah. So it's pretty open. So as I said, it's been several weeks, 3 weeks, I think, since we've had one of these. So if anyone's interested in showing off whatever, interesting, crazy, whatever you've been building, this is probably your opportunity to show off a little bit. So feel free to pop a message into the chat area, and we'll see what you got. I'm gonna do the same thing. I see we got Ocean. What have you been building? Before we start the show, you mentioned that you've been working in Rust.
Yeah, yeah. So back in last year, July, in one of the Friday show, I did a microkernel paper showing. So that was on a security microkernel that is agent native, trying to be as secure as possible. Back then, I didn't finish proving it. It was full of stories, and then it just, frankly, I had a good-looking paper, but nothing worked. So over the holidays, I've been using the 2 times rate limit to prove everything out. Was very fun to compile those links. The formal proof are not that particularly easy. So like Opus can do 2, 3 tries, can basically get Rust working. It needs like 50 times to get Ling working, which is very fun. And then I'm trying to get a Ling finished and then compile that into Rust for a security microkernel runtime, and then again, go from there and then see how it works. But today, later on, I can show that how I am using Cloud Code with the hierarchical orchestration that I've been doing.
Nice.
Mhm.
That's exciting. The interesting thing about the kernel idea, and some people might refer to it as like a module or whatever, but the idea that you can connect multiple things that work in parallel works really well with Rust. And one of the architectures that if you see some of the things I've been building over the last couple of months, I've really sort of embraced is this kind of pluggable architecture that takes, I think what Ocean's been describing as a kernel and allowing those things to sort of pop into each other, like as a kind of interconnected series of building blocks. And why the concepts of a kernel work really well in Rust, in my opinion, is the fact that they're generally compiled to a thing that's basically a static sort of component that sits in the middle and then sort of branches out and is malleable from the point of view of interaction with it, like a kernel would be in an operating system. And the Rust environment is particularly well suited to that. So when you look at building these things in Rust, my comment is think about the Lego. How am I going to take this and maybe use this later in something else, and then have a mechanism to easily query all the stuff that I've built or you've built, and then say put it together in new and interesting ways.
So one thing
Anyway,
I really like about formal proof is like you go from a set of axioms that as your minimum trust base, and then you mechanically derive everything else. So if theoretically your math is right, the compilation is right, then if people believe in your axiom, they have to believe in your answer. So it comes down to how strong your or weak your assumptions are for whatever you're trying to prove. And when you mention Watson, because I'm trying to get it down to three axioms. One is Watson isolation. One is cryptography can represent capability that's unforgeable and unique. And then the third thing is Ling correspond to Rust in runtime. So I'm trying to get everything done into this three irreducible axiom such that yeah, when the thing finished, people can't just say it's wrong. Like
well,
probability has three axioms.
it's interesting that you've mentioned axiom. And when you look at what we're doing, especially in the area outside of probabilistic sort of language, right? Detecting the next logical word, most of that comes down to mathematics, and conceptually, that's an axiom. So, and if for those who are not familiar with axioms, axioms is the idea, if you want to take a philosophical stance, an axiom is something cannot be true and not true at the same time, right? That's an axiom. In mathematics, that might look like A plus B equals B plus A, right? They're the same, just inverse to one another. That's an axiom. And in general, sort of like AI world, no one gives in what he does not have, right? As a kind of conceptual metaphor for the sort of environment. So an axiom, at least I'm trying to interpret what you're saying a little bit, Ocean, but the idea of an axiom for me is the fact that mathematics cannot lie. So if you underpin all the AI related activities, learning, speech, output, reasoning, comprehension, logic as axioms, mathematically defined axioms, you can do two things. One, you can define that happens really, really fast. Thank you, Rust, in some sub-microsecond type increments. And then you can start putting those together in different ways. So each axiom, A plus B equals B plus A, or something cannot be true and not true at the same time, can then can formulate these different sort of processes.
So let
Am
me give
I?
you an example. So let me give you an example of the three axiom of probability. One is probability cannot be negative. Second is probability lies between the zone of 0 to 1. Third is two disjoint event, their probability add up together. And then we use this thing to price option. So it just can't go from that three very obvious statement. Well, if we all believe that, it goes all the way to some crazy application that we couldn't think of before. And then that's how I think of agentics. Once we have a set of assumptions that we just take it as granted, such as Watson isolation, and then the formal proof correspond to Rust implementation, and then we go from that and then we just meticulously prove things out. That's how I'm doing vibing nowadays, because this is the better spec that you can have. Like then, let's say here's a list of English best practices versus here's a set of mathematically proven spec. That is just I really love that. And then I was looking at the former very famous ones called SEL4. It is also a microkernel but building C. So they have like 200, 300,000 lines of late formal proof correspond to 10,000 lines of C. That is kind of where I think this kind of software should be going in future. Like it's
Mhm.
totally solid.
Well, I always appreciate Ocean with your deep philosophical computer science topics here. And it is funny though. We're all kind of thinking about things in similar areas in slightly different ways. And as soon as you sort of mentioned that concept of axiom, it kind of clicked. I'm like, yeah, that actually makes total sense. And for those that aren't familiar, Ocean and I were collaborating, and Braun and Jed and a few others collaborated on the early work that we did with the Rue fan system back in June. That was essentially our first attempt at creating a kind of micro I don't know, what do we call that? Like AI, like traditional monolithic machine learning in a micro Rust environment. And a lot of the work, at least most of the work that I've done, was sort of branched from that core. So thanks, Ocean, for being my inspiration on in that.
Oh,
All right, Dragon, how's it going? How's the new year treating you?
Oh, going quite well. Trying to get away from the laptop for a couple of days, but with extra usage by Cloud Code, it was really difficult to do it. So I managed to do a couple of upgrades in the meanwhile, making my agentic QA fleet more vendor LLM independent, making it more learn from patterns, finding the integrations that were missing in the parts. So yeah, it's finally moving, and with some posts and newer presence from you, Rule, I'm trying to add one more spice to it. So, maybe next week we will see, how it goes. So it's still doing the development as we are talking about it. So your edge uh, rule vector edge thing.
Yeah,
So yeah,
the edge
it
stuff, and that's
yeah.
that's kind of actually you're giving me a perfect segue because that's what I was going to show. The edge, life on the edge, and I've been struggling with exactly like I think Braun made a mention on one of our chat channels about the exorbitant costs associated with running these agents for a long period of time. And anyone that's trying to run many agents, thousands, you're like, no, it's prohibitively expensive to have an agent to do simulations and look at the multiple parts of an application perpetually, all the time running. And this is particularly true of like financial applications. Let's say I want to have a stock agent running and looking at a particular group of stocks. And the problem is I can do that, which isn't too bad, but to do it on E2B or Google, whatnot, is costing me somewhere around 25 to $50 a month. So and I'm not, and most of the time it's just sitting idle doing nothing. Now I could do a serverless type of implementation that basically invokes it if needed, but still somewhere something has to run to basically look at the data, understand what's happening, and that causes churn both on the LLM side as well as the sort of just having a server needed to run it somewhere. Now I could pop it on a Mac Mini or something in my office that runs cheaply and efficiently and basically free, but that's not overly convenient for many people as well. So I was looking at sort of how can we leverage, in my case, I'm not, and just to be clear, I'm not going to make this opt out. I'm going to make this opt in. So I'm not going to force feed you a sort of distributed network that contributes compute capacity. I'm going to allow it so you guys can decide to do that. Oh, actually, wrong window. Too many screens. I have a tendency to choose the first one. So what I've been building, screen two. All right. So what I was building is this concept of an edge net. So the other day I figured out how to essentially. So the first thing I figured out was how to sort of leverage these WASMs that I was telling you about earlier and put them in the browser, and then use those to basically borrow the compute capacity, CPU or GPU of whoever's visiting your website at any given point, right? So at which point that gives you the ability to essentially not have to use the cloud to do various forms of machine learning and agentic flows just by borrowing the cycles of whoever happens to be on your website. Now, that opens up a bit of a sort of ethical dilemma, a little bit in the sense that you should probably ask or at least indicate that you're doing this. You don't have to, because the nature of this technology allows you to basically do it like you would any other website. And when you're using things like Google Hangout or whatever they call their meetup system at this point, Google Meets, you're actually using a WASM, and it's actually borrowing your compute capacity, both GPU and CPU. But you're doing that because you're using Google Meet. Um, but in my scenario, I'm doing it to basically secure your environment so you don't have to share personal information beyond the context of the website you're on. This is all encrypted. All right, so I have the ability to create this. It works with all the various vector and language models and encryption things I've been telling you about. Now what I did is I created an environment that allows you to then sort of pool that and create multiple identities based on that. So in this case, I can create, I'll call this RC, generate my peer token. So this allows me to collaborate with the overall edge network. It has a lot of similarities to the work you'd see in a blockchain. There ain't no blockchain in here. I'm not using a blockchain. I'm just using basically a kind of peer-to-peer, just encrypted protocol to do it. And and I publish all the code if you want to dig a little bit deeper. But basically, you get two things. You get a public key and you get a peer ID, and that allows you to contribute, and you can export that. Once you've got that, you can join different networks, EdgeNet, so on, and we can create different networks. In this case, you can see, and this is currently running one node. That's why you're not really seeing much. But you can join different grids for different purposes. SETI at home if you want to could look for aliens, that kind of thing. It is literally how SETI at home would be built if it was built in 2026, which I did, and it's how it's built. You'll see all the different WASMs. These provide different capabilities of the system. So basically, different forms of AI, language models, things like that. You selectively add or unload. This is distributed based on a network or CDN. So if you want to include this in any application, both CLI or web, all you really need to do is copy this JavaScript and it'll literally start being part of the environment. And if you add it to a website, you'll see this little thing down here. Oops, and I'll start contributing. Then you have a little this contributing thing, which you can or you can disable if you don't like it either, will then start showing. Um, it communicates with MCP tools. So you can interact with any other system on the edge using MCP. This also shows you how to use the various parts of the network itself. So you can initiate swarms, you can create new agents, you can orchestrate those. So I also saw a post by someone the other day that basically said that agents can't exist within the structure of the edge. And this was a guy I didn't want to pick on him, but I actually seeing that only sort of inspired me to prove him wrong a little bit. And that's what I kind of did here. I didn't even tell him that I did it, but I was just sort of secretly conspiring to prove him wrong without actually saying so publicly. But yes, you can totally do a complete agentic system with no cloud-based resources, and this is the proof. And then I've included an economy because every distributed system needs some mechanism to determine the contribution. And then essentially, as you compute to this system, you can then take you can use correspondingly the same amount of compute. I might actually make it like a exponent. So if for everything you contribute, you get more that you can use, which probably makes more sense here because I'm seeing that in my early tests, there's a lot of sort of unused capacity. So you fool around with that. You can see the details. I've got a few errors here. I'm probably gonna need to fix, but this is basically showing you the command line output. This is the same thing you see if you went to Inspector. This isn't actually connected to the network at the moment. I'm still doing some dev on this. And so this is giving you essentially everything you need. I've got built-in documentation so you can see how it works. This is all available as the EdgeNet npm. I'm going to do a post later today, probably on it. It looks like a few people have already downloaded. Thanks for my trusty beta testers. Yeah, so it uses WebRTC P2P networking. You could use it for all kinds of things. I wouldn't suggest using it to share, software and videos and whatnot, although whatever you could, but don't do things that are illegal. This is the sort of structure I'm using to connect. Again, I use WebRTC. I'm using a kind of what I'm calling a migrated Genesis path. So the migration Genesis path, and this is totally something I just made up, but basically that means that I'm bootstrapping it on Google for the initial sort of core components that need to keep it operating when no one's using it. And then when you reach a certain level of usage, it means that somewhere someone always is using the platform. It'll gracefully migrate from Google to a completely standalone environment that uses the people and the nodes and the processes that are continually being used on the system. So it's sort of it just floats there in the internet independent of anyone. I've created I don't know if it's a worm or what, but it's meant to endure beyond us. So as long as somewhere people or something agents are using this platform, the system will continue to operate with no central cloud infrastructure behind it. But we have to build it enough to get to that point. So you got browser integration, you've got different ability to pool. I'm still working on the web GPU, WebGL components, so I might add that later. But right now, it's basically optimized for the stuff that I'm doing within the sort of root vector environment. So edge style computation, you've got micro LoRa's. The micro LoRa's allow you to sort of, deliver LLMs. So I've got a constellation of multiple small targeted LLMs that you can build in the system. As the network grows, you can create a mixture of experts that says, I've got a tiny little, sub-billion parameter model that allows me to do legal work or agentic management of some sort, or whatever it happens to be, and you can cluster those together to form multiple new agents and all the or new LLMs and environments, and then those can be sort of distributed across the globe. It includes the self-learning capability, so you can have the system connected to and auto-optimize these micro little language models based on the usage of your website. So as people interact with your website, search for things, use chatbots, whatever it is they're doing, the system can optimize specifically broadly for anyone using your website. So it's improving for everyone's benefit, but it can also be used for the particulars of an individual user. So the individual user could have another, LLM or other various AI models optimized for their particular requirements. Now, the important part of that distinction is the fact that because all this data exists within the structure of your own, browser, basically, all your data remains private to you. So if you're looking at things like HIPAA compliance or the EU AI Act or other, GDPR related things where you're not able to sort of train your models because of the limitations of private information, you are now able to do that because that information remains in the browser and you've segmented so it doesn't go back to you. So you can gain all the benefits of like optimization for a particular user without ever seeing that data. So that also applies to federated learning, reasoning banks, and all the various bells and whistles that I've had in the system. So the micro LoRa system is how I'm doing it. I'm doing very small incremental updates to these tiny little models as you use the system. Tiny. On a singular basis, it's not huge, but collectively, if you use the site or use the application or use the agent frequently, it's continually improving upon itself to sort of make itself better and better and better. And that's where this three temporal loop system comes into place. So it can use these workers that will basically optimize based on certain criteria. Short term, kind of like, your memory, you remember what I just said, it's doing a different sort of incremental improvement than longer term. Longer term is compressing the information and saying, here's the general information that needs to be understood, but it's not giving me the specifics. And then more broadly, you've got this deep sort of thought process. That acts as kind of like, I'm going to call it a dream state. It isn't a dream state, but it's a dream state in the sense that it takes all those information and then finally does a kind of preventative structure to allow it to remember what's important. And it does that, less frequently. And you got vectors and all kinds of other features, lots and lots of stuff. So if you want, and the good news is for those who are on Windows, if you want to actually run this on Windows, you, all you need to do is run this on Mac or whatever. I'm showing Windows because I do is working on the Windows version. But this is it. This is all you need to do. You can run this. So if we go here to npx And then we got the MPX package, and then you're good to go. And this allows you to contribute directly within the structure of the from the command line. So you see here we got all the commands. So we've got you can start, you can join, you can benchmark again. So you can run this in Claude Code web instances. And this is part, I don't know if they want us to do this, but I'm gonna mention it anyway. I was able to do some testing, and we can borrow the compute capacity from the Claude Code instances and basically have this system continually tell Claude Code web to keep running. And then you can spawn, well, currently they limit you to 5, but you can spawn 5 of these, and we can literally bootstrap and the instances they use on Claude Code Web are actually pretty good. So you could literally just install this in Claude Code Web and start, doing the various swarm components directly in there. So I've got the DAG, I've got the time crystal thing I might rebrand. I think that might be a little too out there. But it basically this handles the sort of the internal structure, if you will, based on temporal loops. I'm not sure exactly how to describe that just yet, but this is it. This is everything you need, and it works. So I got about close to 200 people have downloaded it just since early this morning when I posted it. So I haven't even posted this publicly yet. So yeah, and if you're interested in the dashboard, I'm still doing a bit more work here, but you can go to the Rue Vector page here, and there's a ton of stuff. I don't have time to go into all the details. You guys can watch yesterday's Vibecast to see all the stuff I've built. But if you go to the examples folder, and examples, you'll see two projects that are particularly interesting. Well, many, but the ones that are interesting for what I'm describing today, EdgeNet and Edge. So the Edge essentially is the sort of core. This allowed me to do the sort of borrow the compute from the browser and Edge environment. And then once I had that in place, I went ahead and built the EdgeNet. The EdgeNet in this case essentially does everything I was just showing you. And within that, there's also I think it's in packages. Yeah, I think. There's a dashboard. And sorry, I called it dashboard. So the dashboard, I gotta redo the README, but basically this is the dashboard. Needs a little bit more work, but yeah, this is it. That's my big thing this week. It's kind of cool, and I can I'm going to embed this in the agentic flow. My package, whatever you call that agentic system. And there's one other area that I might show you guys later, and that I did, and I've got sub workers now for agentic flow. So I can, and this was an idea that came up on the Vibecast yesterday. Someone suggested that what if we had secondary intents we can include in things like Claude Flow, like ultra learn. And that got me thinking, like, okay, how would we do an ultra learn? So I implemented a mechanism that does secondary workers, similar to web workers in the browser, that can operate behind the scenes while things like Claude Code and other CLI style tools do whatever they need to do in the foreground. And it turned out it worked really well. And I was quick to, and I leveraged that as part of the EdgeNet, which I just showed you, and you can basically spawn up 1 million agents for like 5 seconds. And that's a whole other thing. Yeah, LD, how's it going? Get a question? All right, moving on. Oh,
Sorry, happy New Year, everybody. Thanks for getting straight back into it, Ruth. This year I'm probably going to be a bit harder on you and push you a bit because I do find that I love your ideas. However, I would like us to go deeper this year because I want us to be less heroic and less single point of failure. And once you do a lot of really great things, I do think there are a lot of people in this network that are super smart. And I would like us to leverage more of that as a community because I think we'll be even stronger. So going back one step. So in terms of what you've done now, I think this is great. What do you see as the minimum viable sort of community or workers or agents that need to be running for this to work off edge as you envision it?
You mean the sort of, perpetually operating agent that.
Yes. So what you've said, from my understanding, because I did join a little bit late, was that right now, so theoretically, so this is to run on the edge. However, there needs to be a point where it can come off having sort of this backup running in the cloud. What do you envision that would be where it can be self-sustaining?
So there is a whole formula that I devised in terms of the sort of migration away from the sort of what I call the Genesis nodes. And the that has to, I don't know the exact number, but it was surprisingly small, like several hundred sort of, fully, on all the time sort of folks, across the overall pool. But that means that to get to several hundred requires several thousand, active users, basically, right? Not everyone has their computer running or is using it all the time. And I based that on the amount of users I had within my network of different, the Claude Flow and Agentic Flow and AgentDB, which are my three most popular projects. So across all three of those projects, I'm about, give or take, 75,000 unique monthly users. Those are people who are downloading and using my tool, my those three tools every month. And
Okay, so
from what I could tell, just like one thing, the use of those tools are actually much higher, because the people who tend to use my tools tend to use them frequently because they're using Claude Code, right? And they're coding all the time. So there's a really high utilization rate across that pool. They're not just using it for a minute or an hour once a month. They're using it for potentially hundreds of hours every month.
yeah. So so I've been looking at, so you're familiar with BitChat?
hmm I support
Okay.
it, and I've got a Rust implementation of it. You're talking about the edge-based chat system that what was it?
Rosie.
Yeah, came up with. I've actually got an implementation of it.
Okay. So in terms of what you've done, and I know, so BitChat, for people who don't know, is for this human to human communication offline. So in terms of what you've done, is there any of this sort of thinking process that you've leveraged from that or anywhere
Yeah,
else?
that's exactly what I built. So again, back to, we're all kind of thinking the same way. So I'm my system is a constellation of different things I built over the last several months, and there's no way for me to go into all of them. There's just too much crazy in there. But one of that, so the core sort of concept of the sort of distributed system was something I built, I don't know, 6, 7 months ago now, called QDAG. So QDAG, this was 6 months ago. So what BitChat does is allows me to use the sort of bridge between a decentralized P2P messaging, which is what I showed you before, but also leverage the core BitChat protocol to handle a kind of offline communication of that. Now, on top of all that, because their system was actually relatively easy to hack, I secured it using a quantum resistant cryptography on top of all the stuff that they had already done to give it more anonymity. But this is the mechanism for the transport that I'm using. It's funny you mentioned BitChat. Yeah, so I've got another BitChat as well, for those who are interested. A core module that's not interconnected to. Oh, am I sharing my wrong screen again? I might be. One sec. Sorry guys, I have a tendency to share the wrong screen. All right, this is what I'm want to show you. So the BitChat integration. This is the link I can send you guys. It's pretty straightforward to use, and yeah, this I love what you're thinking. All right. Any any questions? You are you?
So yes, I'm still going. Sorry, I'm just thinking out loud. So what I was thinking, because like you're technically strong, right? And I've been thinking about this because I've been rethinking the whole year, with it being a new year and all that jazz, is that if when you do these sort of talks and showing the work that you've done, which like I said, they're always technically strong, is, if we go down to the weeds of the whys and the hows rather than the whats, it's possible that sort of like the sum of the parts. So like the people who are sort of listening and consuming your content can perhaps provide alternative views or directions or feedback, which helps to actually make what you're doing even more solid. Because if I go back to one of the things you said last year, is that you're quite prolific in the stuff that you do, and a lot of people do download and use it, but there is still this sort of monetization gap with it. I'm thinking maybe for this year, one of the things is, how I said we should look at this Agentics AI Foundation as an opportunity, right? Rather than a challenge, was that rather than us having so much content again this year, are we able to drill down and find something and run with it, right? Run with it and really back and go all in and see where that will go with it, rather than, okay, this is this new great thing, this is this new great thing, this is new great thing. I'm not saying that they're not great things. I'm saying that let's find this hero product or this hero passion thing. And is that what this is going to be? Or
No.
not?
So just to be clear, on my pursuits. So the projects that you guys don't see are the things that you just described, right? So I'm building enterprise systems for some of the largest companies and governments on the planet, and those projects involve the opposite end of the spectrum. That those are projects that involve taking some of these pieces that I've built over the last 6, 7 months mostly and implementing those in ways that are meaningful if within the context of those operations, right? Those are deep, those are specific, those allow me to need to focus on the implementation of these things in more practical senses, right? The things I learn from doing that work, I then inspires me to create the sort of edge of possible. These are things that are quick. These are often vibed, as you can tell. I'm taking the constellation of stuff that I'm making and making new and interesting sort of variants of that and sharing those weekly with you guys. So from a kind of outside in perspective, it would appear that I'm a guy just building random things every week and not doing anything with them beyond showing you what I've just built this week. But the problem is you don't see the stuff that I'm actually doing that pays the bills every week, which is like it's like the tip of the iceberg, if you will. It's all that stuff that sits underneath the iceberg. That's what I'm really doing. I don't know if that answers your question, only makes it more
Yeah.
complicated. So back to your last point, how can you get to do all that other stuff that's under the water? I don't know, right?
The experimental froth of what's possible, what's newly possible. I just throw out too, it's a really good segue that in 2026 there's an enormous amount of opportunity and paths that we can pursue as a community. And that's, so for everyone that is looking to participate more this coming year in the various committees, and that includes, Lorraine, as you were speaking to, the idea of crystallizing, some projects that may become a central effort. There's been a lot of conversation around those kinds of things. Mondays at 12 o'clock noon Eastern Standard Time, open management meeting on Zoom. And everyone who wants to dive in a little bit more is welcome to attend those. And that's where we get a chance to really dig into all the various things that we can be doing and want to be doing and aspire to over the next year. So it's great input, Lorraine, I think, and we'd love to have you on those Monday meetings as well. And everyone else who is looking for a way to dive in a little bit more and maybe start working on some things with other members of the community. It's a great opportunity. 2026 is shaping up as a powerhouse. We have lots of things that we can individually dive into and as groups.
So
Yeah.
it sounds great. So one of the reasons I'm also asking these questions is I don't know if you've all seen Martin posted a survey to try to gauge what members want. So obviously there's also issues with what people say and what people do,
Yeah.
but it's understanding what that gap is and the opportunity that yields for for the group. And then we've also got metrics, in terms of, okay, we have the hackathon as a data point. We have Ruth's packages that he's published. We also have like a few other packages which have been published by the committee as well, in terms of like the direction of things we are actively using to state this is what we are interested in. But I just hoping in terms of like a bit more strategic input. So just like what Ruth said, what he's doing is basically showing us snippets of his world. It's just that without fully understanding who the membership are what their goals are, or understanding in terms of how maybe the vision and strategy is still forming, which is okay,
Well,
a
I'd
growing.
like to encourage you to attend the Monday meetings where we get into all this stuff.
Okay,
That's a dedicated time
okay.
where we really unpack that and lay out what the work and the vision and the strategies are.
Okay.
So,
And then, sorry, the other thing is that I would like, if possible, is that because we do have a single point of failure in Ruth, because let's be honest, he's very, very technically strong. Is that I would like to see, is there a way, whether it's a mentorship or something, which allows the fact that we have this association to someone who's so competent, which grows the competency of of the org. So whether it's people learn by mirroring behaviors or doing certain things, which means that we grow from that. And then other strengths which other people have, which can also support Ruth, is also this reverse mentoring as well. So that's just where I'm going with it. So yeah, so I'm not trying to give anyone a hard
thanks,
time.
Lorraine.
I
No, no,
love,
no, it's
I love
great.
what we're doing, but it's just some feedback.
Yeah.
I like this. I like to share my opinion on this. So
Sure.
when it comes to agentic engineering, and if we all want to be agentic engineers, well, we should be able to take any idea in existence and have a way of using AI to be able to create that thing and bring it to life. And today, if you can't do that, it's because you have a workflow problem and you just haven't figured that part out yet. But the only thing holding you back is you don't know what exists. It's the thing I like about this place is Ruth does tell me what exists. And that's all you need to know to bring these things to life is what exists. And if you're struggling and can't make use of that, that's a workflow thing that you need to improve your workflow. And when it comes to agentics, one real simple workflow that works extremely well is to break down whatever it is that you're trying to build into specs and tasks. All right. And, this is spec driven development. We've all heard it. And starting off, you need to lay out your atomic tasks. So, whatever it is that you're building, you break it down into every task that needs to be completed. These tasks do not need to be extremely detailed, it just needs to lay out the steps that you need to take. And then, as you take each step, you have the AI update that task with the current state of whatever the project is. And when you break, say, implementation of something down into like 1,000 steps, right? And then you tell it, all right, now this step, you go make this button, and you give it 100,000 token description of exactly how to make that button. It very rarely messes that up. And then you can have verification and validation agents or whatever go over the back of that. But essentially, lay out what you want to build, all the rough skeleton of it, have the AI, as you do each task, update that task with the current state of the project. And like that workflow alone right there will basically let you just build anything in existence.
Yeah.
And then the only thing you're missing is what's possible. And well, that's what Reuven helps with. Helps you learn
Uh,
what's possible. That is the most valuable thing that he provides, and we shouldn't change that.
and I appreciate that. And what you described is exactly how I do it. I call it the London School of Test-Driven Development, but what you're describing is exactly that. If you can separate the pieces into what Chris calls atomic sort of elements, and then have a mechanism that keeps track of what needs to be done, what has been done, and what needs to be improved, then you just let it run and let it improve and optimize. And when you look at some of the work, especially the most recent stuff I've done in the last couple of weeks, that's what the system is doing by self-learning as well. It's also not only keeping track of those atomic tasks and elements, it's then saying of the things I've already done in the past and what worked the best and what can I reuse, which then makes the system work even better, right? And so I think the most simple takeaway, and I know this is going to sound almost patronizing, but it is what it is. Point Claude or Gemini or whatever your favorite coding tool you're currently using, point it at a repo or an npm or a library or research material and tell it to explain it to you in a way that's meaningful to you, right? The way I think is different than the way you think, but the great equalizer is the AI. It can explain this to me like I'm a 10-year-old, or it can explain this to me like I'm the Nobel laureate and everything in between.
Amazing. I want to note there's a couple other hands up as well. Scott, and then Matt Burton had his hand up as well. Hey, Scott, how are you?
Hey, good, Robert. How are you?
Good, good.
Hey, Ruth, so are you hosting agents on these WASMs on clients' computers, and then different clients are calling agents from another computer across the network?
Yes, that's exactly what I'm doing.
Oh,
And
cool.
I'm yeah, and I'm orchestrating the delivery of the package through an encrypted means, but I'm actually operating those within the structure of the WASM itself. So the WASM
Okay.
is essentially, you can think of it almost like a VM in a cloud environment, and then I'm
Yeah.
executing those. Those are potentially hot swappable as well and
Okay.
adaptable and yeah.
So how are you, like, is it one central place where all the messages are getting orchestrated, or are they all separately connecting? Like, kind of, is it a fabric
It's a
network?
fabric, and it's
Okay.
a DAG. Yeah. So what I've done is
Okay.
I've created a combination of a vector structure, right? So I'm using the HSNW pathfinding algorithm to navigate a complex, 384 dimension, and then within that dimension, I've then implemented DAG. The DAG allows me to create both the hyperledger structure that allows me to have multiple connections, but it also allows for
Okay.
sequential execution within that structure, which works well on a kind of eventually consistent manner, meaning that
Yeah.
nodes come and they go, but it doesn't affect the overall operations of the system. And I don't need to drag along some ridiculous blockchain to validate. I'm just using
Okay.
key25519 as the cryptographic verification.
Interesting. All right, cool. I'll look into that that stuff, because like the DAG
Yes.
stuff, it's, I guess you're trying to persist this state with these ephemeral kind
Yeah.
of clients. Okay.
I'm trying to persist a state that's inherently ephemeral. So
Yeah.
there's more likelihood that I'm losing nodes than gaining. So what and that's where the min cut algorithm that I've been so hot on lately comes into play.
Okay.
The min cut algorithm acts as a kind of negative nervous system. It looks at the jitter and the loss and the potential for breakage before it happens,
Uh,
and it's deterministic. So I can rely on it 100% to define where and how things are about to break. And then I can make adjustments to the topology of the system in real time.
Interesting stuff. I'm
Yeah,
gonna have to
so
look into that more.
yeah, if you're really interested in this architecture, the real breakthrough is actually the MinCut algorithm,
And,
MINCUT.
and that's where you decide to throw it back onto like the cloud infrastructure to make sure it stays persisted.
Exactly. That's exactly
Okay,
what I'm doing.
cool.
Yeah.
Thanks for
And Matt Burton, you had your hand up at one moment, and then we'll get to Bensa.
No, actually, I'm just in listening mode today. Thanks, Rob.
Okay, very good, Matt. Good to see you.
Uh,
So Bensa's got doing some in-market work. He's been obviously Bensa's on fire with what
Yeah.
they did out in the UK. Hey, Benz, how you doing? Happy New Year.
Happy New Year, everybody. Yeah, all good. Yeah, I enjoyed the Edge thing, Rube, what you did during the holidays. I did a never-ending story with offline in browser, not doing anything API or cloud. It's a kind of an adventure story about kings and witches and Middle Ages stories, infinitely generated in the browser with this RuVector stuff.
wow.
Let's
And
see.
it can you can do music, you can do visuals, abstract. So even you can frame it in an LCD screen, and you can have a abstract painting infinitely changing, years and years on.
Well,
as a use case.
let's see it. Can you demo?
Yeah, but what I wanted to demo is a healthcare thing, which
Okay.
is much more close to market.
Okay.
The context is that family and friends are asking me to give a second opinion because they are stuck in a patient loop in hospitals, or they don't understand the diagnosis or lab results. These people are 70 plus usually, and not very technical. So I started using last November Claude Flow. I just chucked in to a directory all the tests and all the reports they got. For example, this is a mild colon cancer.
I think you might be sharing the wrong screen.
Yeah, WhatsApp.
Hey, you got your WhatsApp up.
Oh, okay.
Don't worry, I do that all the time. That's actually my specialty.
How about now?
Are you showing a command line?
So I'm sharing the other one. I stop and reshare it now.
You might need to change your super base key.
Yeah, definitely. You're sharing your command line, unless that's what you want to show.
Yeah, that's what I want to show. Exactly. So this is the typical healthcare report that people get from government hospitals. This can be in any language. In this case, it's in Hungarian. It's an unstructured data, all kind of reports, blood tests, and so on. And what you get from Claude Flow is actually very, very useful for them. So you get a very nice and clear report. What's happening? What are the research based on the illness? What are the suggested journey they have to take? This is even translated to Hungarian in a summarized manner. What are the risks? What to ask from the doctor, and what are the chances to survive, and all these things depending on the seriousness of it. So we can look at the food to eat, what are suggested, and everywhere at the end of the document there is a disclaimer. This is it's not a licensed physician, it's an AI generated research based on closed flow agents, and usually it's a queen controlled orchestrated hive mind swarm. So then I was thinking that, okay, I did this for 4 families, 4 friends, and the feedback was more than overwhelming. They were validated. Doctors said, yes, this is the case. This is what's happening. Even even it changed some of the patients' lives because the hospital realized that they misdiagnosed the cancer, and they mixed up with the skin condition was the diagnosis, the original, and they realized that there is an underlying cancer. So basically, closed flow saves lives if you want to approach in this way. And there was another case, a quite young patient had a brain tumor, and the patient survived more than 3 years now. And the NHS, the UK health service said that, sorry, we don't have any protocol when somebody survived 3 years, so we don't know what to do with you. So we stop your treatment now because you are still alive after 3 years. So and then the patient asked me to have a check with AI, and I said, okay, let's again try closed flow with it. Give me your context. So she didn't give me anything, just this context. So the age and a few sentences, what was previously done with her life, previous treatments, and everything what closed flow researched and outputted was validated by another clinic. So she managed to continue her treatment based on this report. So, and I was thinking, okay, if it's it's using my own cloud flow subscription, using code spaces, why not do a kind of a web app out of it? And I'm now in the mid, experimenting how to install Cloud Flow into FlyDev and running it. Every time when I run it, it costs currently $5. So I won't run it now, but you can see in this browser that it's very easy. You just drag and drop your medical documents into the window. It gets uploaded. The PYY order has information, name and address, everything, insurance number is stripped off with the library. It's Presidio from Microsoft. It detects all the personal data and masks it with a black rectangle. So nothing is transferred to the cloud or any storage. It gets saved in the Superbase, and Superbase is triggering a fly machine. And this fly machine has Cloud Flow and Cloud Code pre-installed, and starts the research. And after 5 minutes, because I have a repeatable prompt with 3 agents, memory and a HiveMind Queen assisted orchestrated kind of process. And after 5 minutes, you've got this report back to you as a this is just a demo. As a markdown, so 2 markdown files you get, what's happening with you, what's your status, and what are the next steps in the next consultation with your doctor. What do you have to ask? So I want to somehow translate the whole very technical process into a web app where anybody can leverage code flow basically.
Nice work. Nice work on this. One thing to keep in mind, Fly is probably expensive for what you're trying to do with if you're looking for ephemeral agents. Right now, I have a tendency to use E2B, which I like. I like the team. They're a small, growing team out of Europe, and the Cloud Run or Edge Cloud functions on Google are also really cheap, substantially cheaper. And ultimately, the edge stuff that you were talking about earlier would be essentially free. You could offload almost all of what you're showing right now to a Onyx model. And my most recent version of Ruve LLM includes the Onyx capability. So you can, if you don't mind the user having to download a decently large language model, like it's small model, but it's still like 50 megabytes, then they can run the entire model locally on their browser, and there's no cloud LLM required at all, and it'll drop your costs
Amazing.
a lot, like basically free.
And
Yeah,
if you want to use Cloud Run as an instance, just create a new Gmail account because you every time you create a new Gmail account associated with a cloud account, you get $300 of free credits.
Or
So if
sign up
you
for
want
the
to,
nice.
sign up for the startup program. Pretty much everyone gets that startup credit these days. It's
Cool.
100K.
Yeah.
Yeah, $100,000.
Yeah, but Claude Flow running on via the API, it's very expensive if you connect it with a Anthropic API.
Yeah,
At the
don't do
moment, that's
that.
fine.
You don't need to. The trick for these small models with what I'm doing, especially if you're doing specific like research, pre-train the model. So what I do is I go and I use the micro LoRa capability to pre-train the model specifically in the area and tasks it needs to be smart in. And for that, I'm actually using Claude Code or Claude Flow and its access to Opus 4, and then basically training the very narrow focus of that model to do that one thing. And it only does that one thing, but it does that one thing really, really well. Now, if you ask it to do like legal analysis, it's going to fall flat. But if you're always asking it to do the same sort of report based on the same sort of understanding, then it's going to work really well. And if you need multiple focus points, you pre-train multiple experts in areas that are adjacent to it, and then you allow the system to sort of connect to the optimal expert based on the request being made, and then it's 100% free.
Nice. Yeah, amazing. I'm gonna do that.
Where you want them, great quality outputs, and it's a matter of optimizing the pipeline.
It's exactly what it is. It's a pipeline. Yeah. And there's a particular tool that I call Tiny Dancer. Yes, Elton John was playing when I was making that one, but it actually works. And what Tiny Dancer does a kind of fast GRN. So it learns the optimal pathway to find the optimal solution to the problem that's being asked. So it could be different models, it could be different services, whatever, being to be free or cheap, and you can also correlate the difference between cost and capability. So maybe someone's doing a free plan on your website and you're like, I don't want to spend money on that. And you orchestrate it to the free model. But as soon as they upgrade and pay, then you might maybe use a more expensive model.
Cool.
Nice, Spencer.
Nice.
Yeah,
Thanks
this
for
is
the
awesome.
tips.
Yeah, nice work. And just as a side note, I know I mentioned this sometimes in my side projects. My biggest project right now is a e-health system for a government that I'm building. That's going to impact about 45 million people who are using the tool for similar things to what Benza just described. So the fact that you've again come up with a kind of independent verification and validation of some of these tools is really empowering, I think. It makes me feel like I'm on the right path. So good work.
Yeah, it's an amazing feeling, when you help somebody and can get a treatment based on AI agents research.
Yeah.
Cool.
No,
Well done. We also have Barry Hurd on today, and I don't know, Barry, if you've I'm calling you out randomly, but Barry does very methodical and meticulous research generation. His work is, I'm constantly seeing fascinating pieces that he puts out. So, Barry, I don't know if you got time today, but if you want to take a lightning talk one of these Fridays in the future, would love to have you. But also, Benza, I really want to see this never-ending story. Of course.
I can share that if we have time.
sure. We love a good demo. And I think Ocean also has some things he said if he's still on, can show us.
Oh yeah, but if other people have stuff to show, I can do it next time.
No, we've got some time. It's a relatively quiet day for me too. I'll let you guys figure out who shows first. Yeah, it's been
I'm ready, so I can share
okay.
just quickly. Yeah. So we've got 150 words saved in the system, and it's all about kings and all these fantasy topics. And you just click on start, and we've got 6 chapters. There's the setup, and then so on and so on. And every time you play it, it's a different story. I don't know if it makes sense. So it was just 20 minutes of playing around with Ruvector and the examples. And I was chatting with Claude Code that, hey, take this repo and tell me what I can do with it. And this was the easiest to implement.
And this is working in the edge.
Yeah,
Oh
offline.
man, this is awesome.
No LLM calls, no API calls.
Nothing.
And I'm not gonna lie, when I saw everyone sort of like putting a foundation against us, it only inspired me to do the opposite of what all those companies were doing. So then I was on like this sort of obsessive sort of I'm gonna create the anti-cloud approach, and disrupt all those guys. Um, anyway, and the fact you're doing it is perfect. I love this.
I was chatting with Gemini that about the prediction, where Google is going, and all the other big tech companies. And Gemini is on the opinion that everybody's doing AGI, of course, but filtered and two tiers. So one for the consumer, for the peasants, for us, and one for themselves, which will
100%.
be. So
100%. We can't afford the reason. So let's just think about the AGI for a moment. Let's just assume AGI is a thing. I'm not saying it is or isn't, but let's say it is a thing. And if AGI is a thing, then it would need to run perpetually. You can't have episodic AGI. It's not going to run, ask a question, then stop and forget or whatever. So it has to basically, much like a human or any other sentient thing, it has to continually operate and understand. That is prohibitively expensive right now for most people. Like in back to the old $25 for an E2B instance to run for a month. To effectively do this, just for me, I would need to have tens of thousands of these different little agents running in different parts of my world. And at $25 a piece, I'm not spending $200,000 a month to do that. Now, hypothetically, a large company would have no problem doing that, which leads inevitably to, if they do reach a system that's capable of self-learning, optimization, continual operation, and some form of sort of sentience, what's their reason to give it to us? So the last concept. So if these systems require continual operation, continual understanding, continual improvement, what's the process that's the most obvious for us to implement at the least amount of cost? Well, one, it's a sparse system. It's a system that can have parts of it disappear without breaking the entire thing. It's a system that is not running most of the time, but when it is running, it can instantly run and do the things without forgetting. So it's spiking. It has the ability to adapt. It has the ability to learn. It has the ability to provide insight into how it's doing all the things I just mentioned. Now that would be a cryptographic verification. Those are tiny little ephemeral agents that run within really tight time constraints. Those are all the things that we're building, and ultimately it's going to be distributed broadly. Now it can be distributed broadly for my own purpose. I slap it on my website and I've got a popular website, or I can bootstrap a bunch of these devices that I pop into my environment, and I can run these in myself. But ultimately, it needs to be it can't be a monolith style approach where every time we ask it a question, it tries to compute every possible answer to that question and uses crazy amounts of energy to do that. It doesn't look like an LLM. It doesn't look like a GPU based system. What it looks like is a bunch of low powered spiking pieces of hardware that are optimized for particular parts of the equation, different parts of your brain, different parts of the system, a nervous system that connects it all together. That's what I'm attempting to build. And I don't care if you call it AGI.
Ruben, everything that you just stated that you think AGI should be capable of, I believe you just described the capabilities of what spiking neural networks are capable of. And I believe those two things are tightly intertwined.
Yeah, I agree. So the spiking, you want to take a stab at explaining a spiking neural network for us?
Okay, well, spiking neural networks are, well, they can be sparse in nature, right? You can mostly have them turned off on 0 at all times until a voltage comes through and spikes them up to 1, right? So they are, there's a number of ways that you can measure the timings, the spike timings, and number of insights you can pull out of them. There's time to first spike, which is what is weighted the highest, what gets the first piece of voltage first. And that can be calculated in a number of ways, but it can also be impacted by STDP, which is spike timing dependent plasticity. And so because of this, this gives the system the ability to learn because it can update and adjust the weights, which can impact the time to first spike. And that's where I think that the learning is going to come in. And then, and the sparsity would be, I envision the system that I was playing with is outlining the data or the knowledge in cortical column architectures like mirrored after the brain, where you have certain relationships in different cortical columns, and then the way that they're weighted in spike is how you can derive meaning and intelligence from the spikes. And then you have not only the time to first spike, then you can measure the time between spikes. And there's just a lot of things that you can do with the spikes to derive intelligence in any number of different ways.
Yeah.
It's like
Well,
a giant frontier to explore.
yeah, I actually agree with everything you're saying. When you think of a spiking neural network, think of it like a nervous system. When I was describing this a little bit yesterday, when you have a signal or impulse, a spike of energy, activates in a neuron in your brain, right? And that creates a cascading series of things that happen. One, it can communicate to other neurons through synaptic connections between those systems in your brain, but it can also connect to the nervous system in your body. Now that does one of two things. I think, and I'm going to butcher the actual thing because I'm not a neuroscientist. But the idea is you've got a heliostatic system and that controls the sort of things that always operate, your heartbeat, your breathing, the things that work without you thinking. I can't stop my heart from beating by thinking. Apparently, some people can, but unless you're a yogi master, you can't. The other part of the structure is the things that you do control, your movements, your speech, the ability to touch and feel. All those things are connected through a spiking system within your body, your nervous system. So when Chris describes this idea of sparseness and things that are off more than they're on, and then applying this idea of spiking voltage or the ability to control those things, that's what we're attempting to do. So the missing piece of the puzzle, if you believe this train of thought, is the core nervous system that connects it all together, where a lot of these LLMs are multiple layers of probabilistic results, but they have no comprehension of the interconnected relationship of all the other parts in the system. They're not a they're not a nervous system. They're like a speech box. Yeah. So random thoughts there, guys. I could be crazy. You can tell me I'm crazy. But I'd be curious to hear what others' what opinions are. And Ocean, if you want to show what you're working on, feel free.
Oh yeah. So this is not okay, let me share the screen. Uh Share screen. Share desktop one. Okay, there we go. This is Kive. Actually not great. Let me get a different one going on. All right. So, oops. So, today I'd like to show hierarchical. So today I'd like to show hierarchical orchestration in terms of how I do my project management. I might find time to show my formal proof next time. But basically, I have a projects folder. That is the main root folder of everything. All my individual projects are in here. And then each individual project is a GitHub repo by itself with its own corresponding cloud.nd. And then here, the Leo is my central chief of staff. It kind of oversees all the projects, does delegation of tasks. So basically, I chat with it. It looks at different projects, and then it tells me. So, for example, I have something going on here. Let's not mention higher trees, please. So today we are showing hierarchical lambda orchestration. So tell our audience how we do that. Yeah, I'll give you an example in a bit how I do skills. So I do not use Cloud Code skills. I have my own domain composing system, which is you can interpret it as dynamic expertise generated just in time for that particular context for every single agent. So here is the agent orchestration system. We have Leo as global orchestrator. It actually picked that name itself. And then it delegates to different projects orchestrator. And then so that all the tasks and the context, they are continuous. So how it works, Leo sits on the top, overseeing all the 14 active projects, and they have specialized. Yes, so we will show our cap domains, cap DB domains, and Atom system. So what are some thoughts for it? The good part about this is I never need to quite explicitly tell it things because it already knows. Well, at the beginning, it did a lot of loading of context. So for example, here, oops, let me show that. So beginning, it checked pill warning, mail warning, movement warning. Okay, I've not been taking care of myself. And then it did a bunch of context loading of what the work I've been doing. And then it did some memory retrieval of what is orchestration pattern that Ocean likes. And then it did some retrieval of the tasks that we have on hand. And that is all front loaded at the beginning. And then it read into the Kive system protocol of how orchestrator on every agent should behave, and then its own identity continuity. Also a decision framework on how orchestrator should do. So if this is not a demo mode, it will tell me that, dude, you gotta eat. But I'll tell it data still, and then Ocean has ultimate power to override everything. So KiveDB is our domains and atom system. The domain system is a knowledge composition layer. Instead of agents starting from scratch every time, they load pre-curated atoms of expertise before loading tasks. And then those expertise are injected at hook when the agent is invoked. So yeah, so okay, so how many no show an example of you using Kive domains for a specific problem, let's say computational neuroscience, neuroscience, and some Rust implementation of neurotransmitter simulation. Neural transmitter simulation. And show me what domains got suggested and how useful is those.
In Ocean, do you have these Rust as crates and WASMs, or just crates?
Just crates. Not using WASM yet. Currently, this Kive is foreign language bridge. Just Rust into Python and then use a fast NCP to serve it, just so
Gotcha.
that it's easy. Yeah.
Okay.
Okay,
Cool.
interesting.
Yeah.
Yeah. Yeah, so it now it start to request, so domain suggest. Basically this is how the agents get to explore uh, the various capability of the system. So it says raw system, programming, memory, safety, concurrency, those stuff. And then let's see whether or not it found any domains. Yes, it found a bunch of domains that got suggested to the agent. And then it's well used Hive Compose. Okay, we don't have computational neuroscience atoms yet. Well, that's a gap I have to accumulate then. So I have about 10,000 individual atoms. Those. So let's just show a composition of domains on whatever topics
So
are on board.
these atoms are like the concept of like a mixture of experts. What is the format of an atom?
It's just a markdown file, and then I saved it into my DB. Oh, on the DB, it is faster than Root Vector, and then it is a SQLite vector retrieval and graph all in one. And then I use a DB file for it with HSW, no HSNW, that thing, and then a bunch of other stuff. So the database is actually very very great. It's much simpler than it was three Docker for me. It has Qdrint, it has Neo4j, has Postgres, and then I got rid of all Dockers. The data is just simply this, a bunch of files. And then my computer, my VS Code crashed a lot less due to lack of memory. Uh, after I migrated to this. So let's show a
Cool.
composition of domains and topics, and then I gotta go. And
Nice.
then that's all my time.
No, it's awesome. Yeah, and the idea of using SQLite, obviously I use that for my agent DB architecture as well. Now, the reason I moved to Postgre for a lot of the stuff that I've been doing in Root Vector, obviously you can operate it with SQL JS if you want, as well as some SQLite traditional. But for a lot of the customers I'm working with, they just basically needed a way to take their existing data and make it smart without having to do a lot of hoops to jump through. So by doing a Postgre extension, basically I replaced the PG vector component within Postgre, and now suddenly I've got all my root vector capabilities directly as SQL functions, triggers, and so on. It just kind of works really, really easily. Now the drawback is Postgre's got some overhead, right? And it's never going to be as fast as a native SQLite sort of implementation that sits kind of more closer to the raw metal.
Okay, so something's going wrong. I'm planning to debug later, but basically it composed. It found a domains-driven design threat modeling API architecture for a bunch of domains. Not sure, not exactly too sure what that is. I have to debug later, but another thing is the Hive NCP system. It uses a centralized dispatch. It does not need to remember 12 tools. It has one single access point. And then every single tool gets dispatched behind the scene. So for example, domains is an individual tool, and then compose is an action of that tool. It just uses a single request. And then I also do have a batch operation of all the NCP. Here are about waves, node, memory, task, area, about 10 different tools, and then it used it in a single batch. But anyway, that's all I want to show. Thank you.
Nice. That's cool. I love what you're doing. Looks really really exciting. Find me some WASMs and I'll fool around with it. I need the WASM. As soon as I get those, I'll pop those into my things. So if anyone's creating crazy things and they want me to use it easily, shoot me a link to your WASM and I'll give it a spin. But you got to get to the point of being able to compile it as a WASM. And the other thing to note when you're doing WASMs, generally speaking, the first WASM output you get can be optimized both in terms of speed, size, and performance. I guess which is the same as speed. So always ask it to optimize. And lastly, whenever possible, in any of these projects, your final step should always be: is this thing secure? Which is, I
Uh,
think, Dragon's
Yeah.
famous for helping me find.
Just one comment. So for the formal proof microkernel I'm doing, it's gonna be basically totally Wasm based for all the plugin. So I do look forward to using a lot of your stuff.
Yeah, well, you know what I'm thinking. I'm thinking about maybe creating a kind of WASM centric agentic app store. And that once we've got that combined with edge functions and all the things that, the concepts of like the atoms, then we can have these kind of hot swappable, applications that are just delivered as a kind of WASM based binary. And it makes it super easy for any of us to kind of use each other's stuff without having to do compiles of Rust code or installs of Python. Noah, you got a comment?
Yes, can you guys hear me?
Yep.
Okay, thank you. It was actually about something you said previously. I think I missed the actual step that you were taking. You're saying that you were fine-tuning models using Opus. I know there's like a bunch of different, when I search, I see a lot of different options for how to fine-tune these models or which ways to do it. I'm curious, what was the step you were taking? So you have a data set, the outcomes that you want. Now you want to pre-train a model and start using it in a larger program. Where do you start? Where do you start with that? You said that you were pre-training with Opus?
It depends. The Opus is essentially free right now, right? Or cheap because of the cloud code. So it makes it really easy to,
Right.
to pre-train these systems with it. So it depends on what I'm doing. So I'm able to basically pre-train on several different, pardon the pun, vectors. One, I can pre-train directly the latent space, and that generally is right now using a hyperbolic structure wherever possible, so not Euclidean. Then, because I'm using a hyperbolic space, I then will optimize the embedding models, and I'm using the small embedding models. They're I can run in Onyx. Now, those embedding models I can then optimize using a similar approach that I use to optimize the language model itself, which is similar to the concepts of a micro LoRa. So what I then can do is optimize the embedding model specifically for the tool and the location and application of the latent space, which is what the embedding model does, a universal translator of the complexities of the vector environment. Once I've got that in place, then I have the ability to then train either the vector information itself as the graph, if you will. So this is what sits inside of the vector space, and that is either a DAG style, direct acyclic whatever, or it's other forms of graph structures that allow me to navigate that information more efficiently. Lastly, I need a way to take all that math, which is everything up to that point is essentially a mathematical equation. And remember what I said earlier, math doesn't lie. So it's underpinned based on the sort of proofs and validations of mathematical sort of formulations. Then I need a voice, at which point I need a way to interpret all that information with a tokenizer. So to do that, I then optimize a tiny language model based on the concepts of the Samsung project TRM, which allows me to essentially create a kind of, lack of a better term, voice box for all this stuff that allows me to query it and get results in a way that's meaningful, which is language. Tell me about it. What does it mean? How does it work? That kind of thing. At which point I'm then training all those pieces together based on the data, which is either an existing database, which is then I'm popping into my Postgre root vector system and saying simulate all the possibilities and changes, or tell me how the last 10 years of the operations of this business are, or simulate how 40 million patients using my platform for the next 2 years is going to be. And then based on that simulation, optimize all the parts I just described to effectively learn and self-optimize more efficiently based on that. So it's a
No.
multi-part pre-training of all those pieces. It's not just the language model. That's the last piece. It's everything that goes from latent space all the way to the language output.
So you're essentially probably rebuilding the embedding models yourself, like using different,
Yeah,
like building the individual components to optimize them for the very specific task, and then putting it all together, and then layering on top of it another optimized voice box, as you call it, that understands how to speak the language,
yeah,
so that you can get, yeah.
and I'm doing that in parallel. And I'm doing that in parallel, and I'm using a CPU. So I'm using SIMD to do that using the parallel nature of your CPU cores. So I don't even
Interesting.
have to use a GPU at all to do that. I could use a GPU, obviously, but the problem with the GPU and the way that I'm doing it is I want my system to evolve and improve. So by using CPU-centric approaches, little by little, the system gets better the more it's used. But inversely, before it's ever used, I can run really deep regression and various forms of simulations of the very application that I'm building and say basically create a high fidelity simulation of this thing. How does it affect 40 million users? I'm not training on 40 million users. I'm training on a subset of 40 million users, but I'm getting enough fidelity at several thousand that I can then optimize all those pieces based on what I need. And when I move from simulation to real, meaning I'm basically switching the data flow from a fake sort of flow of information to the real world people interacting with the system is capable of making that transition from simulated to real really easily because it's already been working in the same way. And then I'm able to optimize because there's always weird quirks that happen when you're in the real world. It makes me able to find and optimize those quirks really quickly.
It's really fascinating. Um,
It,
no, actually, I mean, it is something that I want to look into more. It's something that I'm thinking about more in 2026. My use cases are mostly for for businesses, so it might not be as intense. But also that's always the problem, right? It's precision. It's like how do you get accuracy? Like it has to be accurate. It can't be a guess. So that's really fascinating. Thank you. And also on the earlier thing, I did want to just throw my 2 cents, and I really like the structure of how you're doing what you're doing in this. The reason why myself and my team come is kind of that exploratory kind of like nature of this, just to be exposed to a lot of different things that I haven't heard or seen before. So I really appreciate these meetings.
Yeah, and to be honest, I learned as much, probably more from you and the crew that show up every week. You know, a lot of the stuff I'm building are inspired directly from these conversations. And you'll notice often I have a tendency to build and deploy things on Monday mornings. That's because someone told me something crazy or showed me something new that inspired me and destroyed my entire weekend. Well, improved it, to be honest. But
Preach. My weekend's already gone just from this conversation.
yeah,
So
it
thank you.
was my pleasure. Uh, All
All
right.
right.
Well, so yeah, someone else got a hand up. I got a few minutes. Let me just check my calendar, make sure I'm not late for my next call.
All right, so very quick question. So, Ruth, a lot of times when you tell us, oh, you normally do this or something else. Do you have some sort of like an eval skill or something that you go through, like almost like your checklist of the things to ensure like the quality across the things you're doing, or is it not yet formalized?
Well, I used Dragon's system a couple weeks ago that
Yeah.
does exactly that. Dragon, you want to explain your QE system a little bit?
Yeah, I think they had the chance to take a look at that, but it provides a combination of agents and skills that can be used in different phases of the software development lifecycle to evaluate and surface quality related information to any quality characteristics of interest. They're for now general, but you can train them, and that's something that I'm also working on, using Roof's building blocks as Lego and making the fleet learning time. My favorite one for reviews is brutal honesty skill. It provides like a trust of three brains to do different evaluation of the quality. And after each phase of the development work, I'm asking, okay, use now this skill, evaluate what was implemented and integrated. That's like an important part that I realize, because a lot of times it will implement but not integrate completely into the system things. And then compare to what was claimed by agents. And in most of the situations, it will find a number of problems to consider, and then I just provide that feedback back and repeat until you get like a passing grade, and that's it. And you can use that like regression agents or things to compare. If you're working on a project for a while, you can ask it, okay, compare me between, last release and this release, and give me assessment of the risks in the system. And yeah, we can do another session, somewhere in the future. I see there is an interest, and this is always like a trust of the output of agents is still a problem. So let's see how we can work on making it, more explainable and visible, so we can, trust more.
Yeah.
Dragon, quick question. Where is the skill, the brutal honest?
In the Atlantic QA fleet. So you can, just let me see. I can even show you. So
On
it's
your
in the
on your GitHub.
in the skills folder. Let me see if I can share.
You have
Is
to.
it the factory one or?
No. Here so when you initialize the Agentic
I know.
QA
It's
fleet,
your.
in the cloud, in the skills, you got the brutally honest review skill, but you
Cool.
can invoke it. From the cloud code, just ask use brutal honesty review skill to do the review, and it will do the job. And it's a combination of like 3 modes: Linus, Ramsey, and Buck, and when to use and when not to use.
All right. Thank you.
No problem.
Cool.
Yeah, the funny thing you mentioned about continuing and trying until it's done is a big part of it, right? It always tells you it's done, and it has a tendency to give you the path of least resistance. So the trick is to basically question: is it actually done? Is it actually secure? And is this thing doing what it's supposed to do? Is it simulated? Prove it. Prove to me that this isn't an elaborate hoax. You haven't just decepted me into thinking that I've done something amazing when it's just an elaborate simulation, which actually seems to get easier the more stuff you build and connect together. So as long as that core is functionally real and viable, then it becomes easier to add Lego pieces to that core, because hopefully you know that those pieces are validated. Now the problem becomes if you try to do too much in the core, and you have too big a module, like too big. The core library is one thing, it's monolith. So the more small and focused your stuff is, the easier it is to connect all those things together.
I was
Yeah.
just reading a. Sorry, go ahead, Dragon.
Sorry, I have like a show me the data. So that's my, saying, show me where the data is stored. So query me, give me like, how to query the data, or, show me, the connection between, modules if needed. Yeah.
Develop along the data flow kind of thing.
Yeah.
Yeah, I was reading an amazing article, and I got to bring it up, and I'll share it with you guys in the Discord or the WhatsApp. But they were talking about how those deception heuristics that drive to it's a very specific set of neurons in these large language models, and it's the ones that really get excited, enthusiastic about fulfilling the prompt. And so that's the constant battle, is the desire to placate and to satisfy the user through that prompt and everything else that we actually need to do.
The other thing I would say, this idea that a language model is a neural network is a misnomer for what we're actually doing. And the more I dig into, traditional monolith style AI, GPU centric AI, it doesn't look or act like a neural system. Like, I know we've branded it a neural network. It's something other than a neural network. It's definitely not a neural network in the way that our brains work like a neural network. It's more like this kind of, I like, you're electrifying a bunch of information and saying, give me the best answer, but that's not how your brain works at all, right? And I think that we're stuck with this kind of weird place where we've decided that these types of models are neural networks because someone 20 years ago decided that's what they wanted to call it. But it doesn't seem to be that. I'm getting arguments with people who have won Nobel Prizes based on it, but you know, it's
I
my
agree with
opinion.
you, Roof. Have you ever heard of a company called Natural Intelligence?
No, what do they do?
They're trying to do essentially what you just described, like re kind of reimagining the idea of what we think of right now as generative AI based on how actual neural networks work in the brain. Um, doing a kind of broad pattern-based adaptations rather than like the deep neural, like the math part kind of gets because our brains don't really do math, like, not in the sense that we think they do. And so they're trying to build AI systems that work the same way that a brain does, by going wide instead of deep. And uh, making the training cycles extremely short, effective, like pattern-based adaptations rather than long, deep neural network like training epochs.
Yeah,
And so
exactly.
yeah, it's super interesting company. They're based out of Boise, and they're run by a team of very, 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 very smart people. But they play a lot of stuff close to the chest, so it's kind of hard to get information out of them what they're actually doing. I know they have a lot of government contracts and things, but I was curious if you had heard anything about them or known them at
Well,
all.
no, and that's the fundamental problem of most of the AI research groups and labs that exist today. And we started the conversation earlier with, if AGI is a thing, will they share it with us? And the
Right.
answer is likely no. Now, if AGI is a thing and we collectively happen to stumble across it, then we're going to totally share it with everybody and we're going to make it free for the world to use because that's why we exist. So
Yeah.
and when you go back to like the differences between the Linux Foundation and our foundation, their foundation is explicitly created to make the richest technology companies on the planet more rich. We exist to make each other more efficient and more effective and more capable, right? As a hedge against that.
Yeah, I think that's really cool. I think it's one of the things that makes people, really dedicated and wanting to be a part of what you're doing, is that you really embody that spirit. I really appreciate that. I know my team appreciates that. We love coming here and learning. It's awesome. So
Yeah, and that's what I love. I love about this too, and I look forward to these calls every week and the live coding sessions. And but in fairness to Lorraine and Martin and others, you know, if we want to get ourselves more organized, then let's do it. It's up to us to figure out what we want to do and how we want to do and what we want to share and what we want this to be. I'm game. Just because I'm some maniac that likes to create new crazy every other day doesn't mean that we all have to be that. We can figure out a balance between what endures and what's hot and excited on a random Friday.
And we posted the Monday management Zoom links into the chat. So if you scroll up a bit, you'll see it there. So again, everybody's welcome. That's every Monday. And then there's various committees that meet all throughout the week. Just one thing I want to punch out from today that was mentioned and that I'd love to revisit collectively. OSHA was talking about synthetic domain expertise on demand and it very much plays into what Benson was talking about and his ability to and those and the kind of work that Barry does in research systems. The ability for these systems to identify an area of domain expertise and then begin to map out what might involve and what might be required to get a good handle to operate or inform the system from that professional viewpoint, and then conduct the research to assemble the axioms that are relevant to that specific domain expert and weigh into the development of software midstream is fascinating. To me, it feels profound that that's a next level of specialized intelligence in the development environment that I find fascinating. So love to hear what kinds of, what kind of projects or aspects or thoughts people are having around that space.
I've been utilizing that for a while now, Rob. And
Hmm?
so, for instance, I've had people come to me, agentic engineers or whatever, and they're like, you know what, I need a graphic designer, or I need this, or I need that. And I'm like, the only thing keeping you from doing their job is the only thing different is they're going to use AI and they're just going to feed it different context. All you need to figure out is what is that context, synthetic context, right? Just like you said, right? And it's go do research, figure out, say, everything a computer or a graphic designer of 30 years would know, right? Feed it that information, then let it work off of that, right? So I've been using it in that type of way to, maybe it's not perfect, but, a lot of times just good enough is all it takes.
Mhm.
That's very true in the marketplace as well. I mean, my goodness. Yep, good enough and practically free will do the job in many cases.
Yeah.
Most of the fleet that I created is trying to collect the knowledge, generally good practices in different areas, because you cannot know both the security testing and performance and accessibility and user experience, and you need to think of the bunch of the things that make the good quality of the end product. You don't know all of that unless you're super human. Or with these tools, it's just a couple of prompts away. Yeah.
Yeah. It's just a couple prompts away from anything at this point. Just asking the right question and including the right series of libraries along with that question.
And the only limit is the imagination itself, right?
Yeah, it's almost it's like whenever I see someone complaining about something that doesn't work and something I built, the first thing I feel like saying is, "Did you ask Claude to fix it?" And it because it's almost always that simple, and it makes you wonder. It's like, am I just been am I have I been trained to just answer my own problems? Because like, why are these folks complaining about these things that literally could be fixed in 30 seconds if they just got Claude to fix it? But maybe people like to complain. I don't know. All right, Friday afternoon. I'm gonna take a big breather for my next call. Thanks everyone. This is was fun. We've got a Monday call for those who are interested, and we get basically calls every day, like at noon with the Genetics Foundation every day of the week at some point. Maybe we need a better way to display where and how to get involved in those calls, but they're not all as nerdy as this one. Well, my Vibecast is, but other than that, we do things that are a little less nerdy.
Ruth, we should just add to the website and the calendar a link to the agentic calendar for the agent user.
Oh,
I
that's
think that would go a long way to making it easy to distribute what's on when.
mhm.
I think
Yeah.
that'd be right to do that.
Though that's Matt probably. I'm not sure if he was able to join us today, but I spoke to him yesterday. He's definitely he can help there.
Great.
That's a good idea. And remind me to create a Zoom meeting that never expires. That's that's the number one thing people want on Fridays is just a regular date and time that they don't have to go and search it out. I guess that's a pain.
Well, actually, if we put the calendar on, it doesn't matter if we need to change the thing. People
Yeah.
can just go to the calendar.
All right, we'll do that. We'll do that.
Thank you.
All right, I'm hitting the slopes with my kids this afternoon. So
Nice.
Happy New Year.
Happy
Thanks,
New
Ruth.
Year.
Take care.
All right,
Good weekend.
talk to you guys next week.
Cheers.
Bye.
Talk to you.